Let us start with the question number 5 on motion graph kinematics. So this is your question. If you want, you can take a screenshot of the question, try to attempt the question yourself, come back, play the video again and look at the solution. So here is the question. This is the first part of the question. It's a long question divided across multiple screens. This is the second part of the question. Then you have the third part of the question. We have the mark scheme as well, which I'll show it to you all later. Alright, so pause the video, attempt the question, and meanwhile do not forget to subscribe to the channel if you're liking the video, if you find this channel helpful. As well as please do comment in the chat box and let me know your feedback, be it positive feedback or if you have any suggestions to improve or me to improve, please do feel free to share. Alright, so I believe you have solved the question. Let us understand and solve the question now. Define force. How do you define force? It is a 1 mark question. So what does IGCSE want you to write as the definition of force? Remember, this is not your primary, this is not your middle school KS3, right? So how do you define force more technically at AS levels? You do not say that force is a push, pull, stretch or squash kind of a thing. No, all these things do not work in defining force when you are at AS level. You define force in terms of momentum. You define force in terms of momentum. Let's see. It is the rate of change of momentum. Why? Why do we say force is a rate of change of momentum? If you remember the formula for impulse, impulse is what? Impulse is Ft, which is mv minus mu. What is mv minus mu? mv minus mu is the change of momentum, right? So how do you define force from this formula? mv minus mu over t. Either you write down the definition of force in terms of momentum like this equation you can write as your answer, or you can write it in words. Both the things mean the same thing. Either you write the formula or you write it in words, both the things mean the same thing. It is the rate of change of momentum. You see the same thing mentioned here, the change of momentum in the numerator, and in the denominator it is time, which means the rate of change of momentum. That's how AS physics at your examination level expects you to write the definition of force. Alright, so that's understood. Let us move on to the B part. So what is the B part saying? The resultant force F acts on an object of mass. Mass is given to you 2.4 kg. The variation with the time t of the force is shown in this figure. So in this graph, now here it is not a typical graph that you have learnt about so far, a distance time or a velocity time or a displacement time graph. No, it is a force time graph. But do not worry, it is simple. It is also given here that the object starts from rest, right? So this is the question. Let us move on to the next screen. This is the same thing. This is the question that we have understood, right? Now let us understand what they are asking us to find out. On the figure 2.2, show quantitatively the variation with the time t of the acceleration a of the object. Include appropriate values on the y-axis. So on the x-axis you are given the values 1, 2, 3. They are also telling you to put the values on the y-axis. You have to show your working, you have to show your graph quantitatively. That means you have to show some numbers as well. So what are you going to do? You are going to change a force time graph into an acceleration time graph. So the first thing that you need to think about here is a formula which connects force and acceleration. So what is the formula that you know of which connects force and acceleration? Yes, you know that. Very, very common and a very well-known formula. Force is equal to ma. Alright, So what is acceleration in terms of force? Acceleration is force over mass. Alright, so from this formula you can derive the equation for acceleration. When you know the value of force, when you know the value of the mass, you can calculate the acceleration. Alright, so let us come to the force time graph now. So what is the value of the force initially? Let us find out the value of the force initially from 0 to 2. What is the value of this force? Let us look at the scale. What is the scale? 10 divisions here. 10 division here is equal to 2 units. So each of the unit here is how much? 10 over, sorry, my mistake, should be 2 over 10. So each of the division, each of the block here is equal to 0.2. So what is this value therefore? This value here is, because this is 2 blocks above 8, so 8.4. So the force value is 8.4 newtons for the first 2 seconds. You know the force value 8.4. What is the mass? 2.4. So how much is the acceleration for the first 2 seconds? What is the value of the acceleration during this moment of time? 8.4 divided by 2.4. So when you will do the calculation, you see it will come out to be 3.5 meters per second square. So in the first 2 seconds, your acceleration is 3.5 meters per second square. You can put some numbers here. So you can take 10 numbers, 10 divisions as 1. So 1, 2, 3, you can count it. Alright, so I have put the numbers here on the y-axis. So how much is the acceleration in the first 2 seconds? It is 3.5, which comes out to be here in the first 2 seconds, which goes all the way till here. Alright, and after the second, how much is the force? From 2 to 4, how much is the force here? The force here is 0. If you read the y-axis value, the force is 0. So if the force is 0, how much is the value of the acceleration? The formula for acceleration is force over mass. So 0 over 2.4, which is 0. Right? So 2 seconds onwards. So this goes up. 2 seconds onwards, the acceleration is 0. So you have converted your force time graph into the acceleration time graph. Let us tally our working with the mark scheme. Okay, horizontal line, horizontal line at 3.5, we have done it. From 0 to 2 seconds, our line is horizontal, and from 2 to 4, acceleration is 0. It's a 4-mark question. You have in between a vertical line as well. So 1 mark here, horizontal line. Then you have a vertical line, sharp vertical line at the second, and then a horizontal line again. You have drawn all the things, and you have taken all your scales properly. Scale is taken properly. You have filled up a proper full graph, right? So you get full marks. It's a 4-mark question. Horizontal, vertical, horizontal, 3 marks here, and 1 mark for putting the labels on the y-axis correctly. So you get your full marks. Alright, so this is done. You have converted the force time into acceleration time graph. Let us move on to the next question. I have carried forward the first part of the question because we'll be needing it, right? But the question here is changed. Now they are telling you on this figure, show quantitatively, the variation with time t of the momentum p of the object include appropriate values on the y-axis. So now what do you have to do? You have to draw momentum time graph. You have the force time graph. You also have the acceleration time graph. You have to now change it into a momentum time graph. Let me bring the acceleration time graph as well on this screen, and then we'll work with it. Alright students, so what I have done here, you have the force time graph, you have the acceleration time graph on the same screen, right? And we are going to attempt this question. We are going to convert these two graphs into a momentum time graph. So when you are starting to attempt this question, first thing what you have to do, you have to write down the formula for momentum. What is the formula for momentum? Mass times velocity. Alright, the question says that initially the velocity was 0. If you come to the first part of the question, it says that the object starts from rest. The question says that the object starts from rest. So initially, when v is equal to 0, what is the momentum? Momentum is 0. This happened at what time? This happened at time t is equal to 0. At time t is equal to 0, v is equal to 0, so momentum is 0. So the first point that you got is your 0, 0. Alright, so the acceleration that happened from 0 to the 2 seconds, acceleration that happened was 3.5 meters per second square. If you cannot see the screen clearly, let me show you where we solved it. The acceleration we had calculated was 3.5 in the first 2 seconds. This was your acceleration. So if you know the value of the acceleration is 30.5 meters per second square. You know that initially the velocity was 0. Initially at this point the velocity was 0. It started with a velocity of 0. You know that the time period is 2 seconds. So after 2 seconds, what will be the velocity? What will be the velocity at the second, right? At the second. This is what I am saying. So let us start with writing the formula for acceleration. So formula for acceleration is very well explained in my theory lesson. Please go through it. It is a very important formula. You should never mess up with the formula. Use the formula as it is written, v minus u over t. V is the velocity which comes later, right? We do not know what is the velocity that happens later, but initial velocity we know is 0. Time is 2. So what is the value of v? If you substitute the value of a as well, you will see that v is a times 2, and a is 3.5 times 2, which makes it 7 meters per second. So what did you find? At time t is equal to 2, velocity is 7. So what is the momentum? Momentum is mass times velocity. What is the mass? 2.4 times 7. So when you do 2.4 times 7, you can do it on your calculator. You should get the value of, you should be getting the value, let us check the mark scheme, 16.8. 16.8. So the momentum will be 16.8. I'm not writing the units here because I do not have space, but if you have space, please do mention the units of each of the quantities as well. So 16.8. So you'll have to take appropriate scale. So now I have taken some appropriate scale. 16 value would come somewhere here. Alright. So the first point of the graph we had got. The second point is at time 2. The momentum is 16.8. So 16.8 starting from here. I'm just trying to locate the point of intersection here and here. So this will be somewhere here will be your point. That's not a part of your graph. Your point will be somewhere here. Now you'll join these two lines. So that's the first part of the graph from 0 to 2 seconds. After this particular moment, after this particular time, which is the second, the acceleration becomes 0. Acceleration becomes 0, the speed is not increasing. That means the speed gets stuck at 7 meters per second. There is no change in the speed from 7 meters per second henceforth, right? If there is no change in the speed, is there any change in the momentum? There is no change in the momentum because the formula for the momentum is mass times velocity. Mass is the same, speed is the same, 7. So momentum is also not changing. So you'll have a line, something like this, a perfectly horizontal line, like this, henceforth, right? So that's how we attempt this question. Here is your mark scheme. The second question is also carrying a lot of marks, 5 marks. So be careful. If you still have any doubts, you can let me know in the comment box, and please do not forget to share your feedback. Alright, so here is your mark scheme. Please go through it. In the next video, we'll be taking up the next question on motion graph kinematics.